Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on part 1 of a 3-part series on algebraic functions for mathematics grade 11, and that is the quadratic function, otherwise known as the parabola. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on part 2 and part 3 of this 3-part video series. And if you have a question or would like to make a video request, please comment down below with the topic and grade you'd like me to cover, or alternatively send all that information to the contact details provided in the description box. Now back to the video. In detail, we're going to look at functions of the form y equals to ax²+q, which is basically grade 10 revision, and that is shifting the parabola up and down the y-axis. And we're going to look at the effect of q and a. Number 2, we're going to look at functions of the form y equals to a in bracket x minus p all squared plus q, which is basically a parabola not only shifted about the y-axis up and down, but also shifted about the x-axis to the left and to the right. And we're going to look at the effect of p. Number 3, we're going to be discovering characteristics one by one using examples. That is your domain and range, the intercepts, the turning point, and the axis of symmetry. Number 4, we're going to be sketching the parabola using both standard formats. The first one being y equals to ax² plus bx plus c, and the second one being y equals to a in bracket x minus p all squared plus q. Number 5, we're going to be looking at how the equation of a shifted parabola changes depending on the direction where you shift. Now we're going to, on number C, we're going to be finding the equation of a parabola from a sketch with given points that are important, and how you change that into an equation. Lastly, at number 7, we're going to look at the average gradient, which is basically introduction to a topic on differential calculus that we will do in detail in grade 12. We have a lot to cover, so let's start. Starting with the revision of grade 10 work, which is functions of the form y equals to ax²+q. If you haven't watched that video, go watch that video, because I address all the grade 10 work in detail. And that is equals to, so if you've got y equals to x², you've got your graph right in the middle with the origin as your turning point. Now, the effect of a on this graph is such that if your a is positive, then your arms look up. If your a is negative, your arms look down. The effect of q is such that if your q is positive, then it means your graph is shifted up. And if your q is negative, your graph is shifted down. Let's look at the graph of y equals to minus x² minus 1. The arms look down because your a is negative, and it's shifted 1 unit down because your q is negative 1, and that's why we end up with a green graph. Now the purple graph, on the other hand, is such that the a is multiplied by a factor of 2. It's still negative, meaning that the arms look down, but notice that it is thinner because you're now reaching milestones sooner. Now let's look at functions of the form y equals to a in bracket x minus p all squared plus q. The effect of p is such that if your p is positive, for example, on y equals to x plus 2 all squared, your graph is shifted 2 units to the left. That's why you end up with a green graph to the left. Now, if your p is negative, that means your graph is shifted to the right. For example, y equals to x minus 1 all squared. That is the purple graph, which is basically the graph of y equals to x squared shifted 1 unit to the right. So if p is positive, you shift to the left. If p is negative, you shift to the right. Keep that contradiction in mind. Now let's discover characteristics one by one. Let's start with the domain and range. The domain is very simple for all kinds of quadratic functions. Your domain is x is an element of real numbers. There is no point along the x-axis where the graph of your quadratic function is not defined. Now the range depends on whether your a is positive or your a is negative. If your a is positive, remember, when you've got a positive a, that means your arms look up. But when you've got your negative a, your arms look down. Meaning that when you've got positive a, you live with a minimum turning point. When your a is negative, you end up with a maximum turning point. Therefore, your range will be such that q is your lowest point, meaning that y is greater than or equals to q. When your arms look down, in other words, when your A is negative, you will lift with a maximum turning point. That means Q is your maximum point, meaning that your Q is going to be less than or equals your Y will be equal to less than or equals to Q. Let's look at example 1. It says state the domain and range of g of x is equals to minus 2 in bracket x minus 1 all squared plus 3. Now we've got the second standard format given to us. It makes life so much easier. Now what happens when you've got the y equals to ax² plus bx plus c, and they say to you find the range. The domain is always x is an element of real numbers on both occasions. But what the range, it's best to find the turning point of the graph because it gives you the range much quicker that way. Now we're going to look at the turning point in a few moments. Now let's look at the range and the domain. The domain is easy. The domain is easy. It's simply x is an element of real numbers. Now the range depends on what your a is going to be like. Our a in this case is equals to -2, which is negative, meaning that your arms look down, meaning that you have a local maximum turning point. What happens is that now your Q becomes your biggest number in your range. So therefore your range will be such that y is less than or equal to Q. In this case, therefore, y is less than or equals to 3 because your Q is 3. Now for the intercepts, that is standard. When you're looking for the y-intercept, you make x0, and when you're looking for the x-intercept, you make y0. It does not matter whether you're dealing with algebraic functions or trigonometric functions. The mantra stays the same. Now let's find the x and y-intercept of the following. To find the y-intercept, you make x0. Okay, to find the y-intercept, you make x0. When you make x0, therefore, j becomes 4 in bracket 0 minus 3 all squared minus 1, which is equals to 4 minus 3 all squared minus 1, which is equals to 4 times 9 minus 1. 4 times 9, take out a calculator. Don't try and do this by hand or by head. You'll make silly mistakes that you cannot afford to make in a test or exam. That is equals to 36. 4 times 9 equals to 36 minus 1. And 36 minus 1, that is equals to 35. Meaning that therefore the y-intercept has the coordinates, that point has got the coordinates 0, 35. Now let's look at the x-intercept of this one. X-intercept, you make y0. X-intercept, you make y0. Okay, when we make y0, we've got 0 equals to 4. 0 equals to 4 in bracket x minus 3 all squared. I think it's minus 1. Yes, minus 1. Take the 1 to the left hand side, it becomes positive 1. 4 in bracket x minus 2, x minus 3 all squared. Divide both sides by 4, you get 1 over 4 on the left hand side equals to x minus 3 all squared. Find the square root of both sides, therefore plus or minus square root of 1 over 4 is equal to x minus 3. Now the square root of 1 over 4 is 2, so that's plus or minus 1 over 2 equals to x minus 3, meaning that therefore, all right, we've got half plus 3 equals to x, meaning that therefore 3.5 equals to x. That's one. The other one is negative half plus 3, which is equals to x. Therefore 2.5 is your other x coordinate. Therefore the x coordinates are 2.5, 0, and the other one is 3.5, 0. There are your x-intercepts. Now for this one, same modus operandi, we do exactly the same thing. To find the y-intercept, you make x0. Make x0. Therefore, h of 0 equals to 0 all squared minus 6 times 0 plus 9. Therefore, h equals to 9. Meaning, therefore, your y-intercept has got the point 0, 9. Now, the x-intercept, same story. You make y0. Make y0. When you make y0, you therefore get 0 equals to x squared minus 6x plus 9. Now, let's factorize this. That will be equals to 0. 0 equals to x and x. And then we've got 9 times 1 and 3 times 3. The combination that will give us 6 in the middle is 3 and 3. So we put that here, and then we've got minus minus because it will be positive for the last term and negative for the middle term. Therefore, 0 equals to x minus 3, meaning that therefore 3 equals to x. X equals to 3. Those are your x-intercept. That's your x-intercept. Let's look at the turning point. The turning point depends on whether you've got what type of standard format. If you've got y equals to a in bracket x minus p all squared plus q, your turning point will be simply minus pq. If your turning point, therefore if your other standard format is ax squared plus bx plus c, then your turning point will be, the x coordinate will be minus b over 2a. And to find the y coordinate, you simply substitute that back into the original function. You'll get the y coordinate for that. Now let's determine the turning point for this 3x squared minus 6x minus 1. Okay, our a here is equals to 3. Our b equals to negative 6. And our c equals to negative 1. Therefore, our x equals to minus b over 2a will be equals to, it will be equals to minus negative 6 over 2 times 3, which is equals to 6 over 6, which is equals to 1. Now, to find the y coordinate of that, we basically find the g of 1. Substitute that 1 back into the equation, so that's 3y squared, 3 in bracket 1 all squared, 6 times 1 minus 1. So that is equals to 3 minus 6 minus 1. Don't try and do this with your head. Take a calculator so you avoid making silly mistakes. So that's 3 minus 6 minus 1. And that gives you negative 4. So meaning that that means the turning point is equals to 1, negative 4. There you go, easy peasy. Now for the other standard format, makes life so much easier. Now notice that you've got your minus 2 multiplied by each and every one in the inside the bracket. So you must make sure that you multiply that out. Let's multiply it out. Minus 2 in bracket x plus 1 all squared minus 6. Now therefore your p is equals to 1 and your q equals to negative 6. And the turning point has got the coordinates minus pq, which are equals to, in this case, minus 1, negative 6. That's all you need to do. Now for the axis of symmetry, that's the x coordinate of the turning point. It will be equals to minus p for the standard format, y equals to a in bracket x minus p all squared plus q, and it will be x equals to minus b over 2a for y equals to ax squared plus bx plus c. Now let's do that. Example 4 says determine the axis of symmetry for each of the following. For the first one, this axis of symmetry is very simple. X equals to minus b over 2a. All right, your a equals to 2 your b equals to -5 and your c equals to -18. Therefore, minus b over 2a is equals to minus -5 over 2 times 2, which is equals to, therefore x equals to 5 over 4. That's your axis of symmetry. 5 over 4 is 2 1/4. No, it's 1 1/4. 4 goes into 5 ones and leaves 1 over 4. So that's 1 1/4. Now for the second one, that's very easy. Your axis of symmetry equals to minus p. And since our p is -2, so that's minus -2, which is equals to 2. That is the axis of symmetry of the second one. Easy peasy. Now let's sketch the graphs, which are very easy to sketch. The graph of the parabola, once you understand how the sign of A changes things. Now if your A is positive, your arms will look up. If it's negative, your arms will look down. And then you find the turning point. You know how to find the turning point now. You find the y-intercept, the x-intercepts, if they exist, and then you find the domain and the range. Sketch the graph of y equals to minus half in bracket x plus 1 all squared minus 3. Mark the intercepts, turning point, and the range of the function. Okay, let's start first with the shape. A equals to minus half, making it less than 0. Therefore, that means your graph looks down. Right now, the turning point makes it very easy. Then the turning point is equals to minus PQ, which is equals to minus 1, -3. That's the turning point. Now the y-intercept, you make x 0. Now when you make x 0, your y equals to -half, 0, plus 1 all squared minus 3, which is equals to -half minus 3, which is equals to minus 3.5. That's your y-intercept. The x-intercept, you make y 0. When you make y 0, you go there for 0 equals to -half x plus 1 all squared minus 3. Now you multiply both sides by -2 to get rid of the fraction. So that is, no, take the 3 to the left hand side first. So that is 3 equals to minus half in bracket x plus 1 all squared. Now multiply both sides by -2 to get rid of the fraction. So you end up with -6 on the left hand side equals to, in bracket, x plus 1 all squared. Getting rid of the fraction, x plus 1 all squared. Now, in order to find x plus 1, you find square root of both sides. So on the left hand side, that's plus or minus square root of -6. The right hand side gives you x plus 1. Now, the square root of a negative number is what we call an imaginary number or a non-real number. Therefore, this particular parabola has no real roots. Now, if you need to know how to figure out what type of number you're dealing with, if you need to know who's who in the number zoo, go watch the video that I've made on the number system, so you'll understand exactly how each number is identified and how it fits into the real number system. So meaning that you will not have real roots, meaning that there are no x-intercepts. So meaning that, therefore, no x-intercepts. No x-intercepts. So now that would, which makes sense if you think about it, because look, here is a graph that looks down and is shifted 3 units down, so meaning that it is far away from the x-axis. We've got the intercept, we've got the turning point, and then now we need to find the range of the function. The range of the function should be very easy. The range should be very easy. The range. We know that our A is negative, meaning that our arms look down. All right, therefore, we've got a maximum turning point. Therefore, the range will be y should be less than or equals to q, which in this case is equals to -3. That's your range. Now, let's plot the graph. Before we plot the graph, let's plot the standard one, the most basic standard format of a graph, y equals to x². You don't need to do this. I'm doing this so that you have something to compare with, and you can see that the shiftings that we say are going to happen will happen. So that's 0, 1, 1, -1, 1, 2, 4, 2, 4, and -2, 4. We don't have any 9s up there. Now let's join the points. Let's join the points on the other side as well. All right, now let's plot the graph of y equals to -half in bracket x plus 1 all squared minus 3. Using the blue color. Okay, what is the y-intercept? Okay, the turning point is -1, -3. The y-intercept is -3.5. Y-intercept -3.5. Y-intercept -3.5. Let's put that down first. -3.5. And then the turning point is -1 and -3. -1 and -3. Here is -1 and -3. All right, now we've got these two very important points. We don't have x-intercepts in this one, so we're going to have to figure out what the other points give us. Now, what happens when x is equals to 1? Okay, let's figure out what happens when x equals to 1. When x equals to 1, y equals to -half 1 plus 1 all squared minus 3, which is equals to -half 2 all squared. That gives us 4 minus 3, so that is equals to -2 minus 3. So when x equals to 1, our y equals to -5. But because of the axis of symmetry, the axis of symmetry is at the turning point, so let's put that down. Axis of symmetry. There's the axis of symmetry. There's the axis of symmetry. All right, at x equals to 1, we've got y equals to -5. Let's plot that. Y equals to -5 at x equals to 1. Okay, make it bigger. Sorry, let's make it bigger. All right. Now, because of the axis of symmetry, the symmetricity of this graph, we know that when we go to -3, is it negative? No, when we go to -2, -2 will also give us -4.5, and then -3 will also give us -5. If you don't believe me, let's write that down. At -3, at -2, at -2, so we've got -2 plus 1 all squared minus 3. That's equals to -half, which is -1 all squared, which is 1. Okay, so that's -half minus 3. That's -3.5. So that will be -3.5. And then for y equals to negative 3, we'll have y equals to negative half, negative 3 plus 1 all squared, which is minus 3, which is equals to negative half. Negative 3 plus 1, that's negative 2 squared, which is equals to 4, minus 3. That's equals to minus 2 minus 3, which is equals to negative 5. So the symmetricity of the graph makes it easy for us to plot those points without even worrying about calculating the points. So for negative 2, we're going to have negative 3.5, negative 3.5. For negative 2, that's negative 3.5. And then for negative 3, we're going to have negative 5. And then they will be duplicated like that, the point. So now let's join the points together. Okay, let's clear the page first so it's easy to see what we're drawing. Okay, now let's join. Okay, let's join the other side. And that's what the graph should look like. Okay, now let's see what the graph calculator calculated for us. And it's exactly what we also calculated for ourselves. So the graph is accurate that we've drawn. Next question. Sketch the graph of y equals to half x squared minus 4x plus 7 over 2. This one, let's go back to our favorite color. And this one, we know what our a is. Our a is equals to, our a equals to half. A is equals to half, meaning that we've got a graph that looks up. All right. Now let's find the intercepts, the turning point, and the range of the function. Okay. Intercept. Let's find the y-intercept. Y-intercept, we know that we make x0. Okay, when we make x0, y equals to half 0 all squared minus 4, 0 plus 7 over 2, which leaves us with 7 over 2, which is equals to basically 3.5. Okay, and then for the x-intercept, we make y0. When we make y0, this is what we have. 0 equals to half x squared minus 4x plus 7 over 2. What we need to do is multiply all everything by 2. So that gives us 0. 0 equals to x squared, to get rid of the fraction, minus 8x plus 7. Now factorizing this will be very easy. We've got x and x. The only factors of 7 are 7 and 1, which gives us 8. So that's minus 7 minus 7, x minus 7 and x minus 1. Therefore, x minus 1 equals to 0, or x minus 7 equals to 0. Therefore, x equals to 1, or x equals to 7. These are your x-intercepts. Go to y-intercept. Now, what is the turning point? Turning point, the x-coordinate of the turning point is minus b over 2a, which is equals to minus, our b is equals to negative 4, negative 4, okay, let's fix that, negative 4, all over negative 4 over a. A is half. 2 times half. 2 times a half, which is equals to 4 over 2 times half is 1. So the x coordinate of the turning point is equals to 4. Now let's figure out what the y coordinate is. So that is equals to half 4 squared minus 4 times 4 plus 7 over 2, which is equals to half of 16 minus 16 plus 7 over 2. Half of 16 is 8, so that's 8 minus 16 plus 7 over 2. 8 minus 16 is minus 8 plus 7 over 2. Lowest common denominator is 2, so that's minus 16 plus 7. Take out a calculator. Negative 16 plus 7, that gives you negative 9. That's negative 9 over 2. Negative 9 over 2, which gives you, how many times does 2 go into 9? It goes 4 times and leaves the remainder of 1, so that is equals to negative 4 and a half. That is the y coordinate of the turning point, meaning that the range, remember you've got your graph is looking with the arms up, so the range will be y is greater than or equals to negative 4 over negative 4 and a half. That is the range. Now let's draw the graph. Before we draw the graph, let's draw the standard one. You don't have to do this. I'm doing this because I want you to see how everything changes based on the equation from the standard basic format. So that's 0. And that's 1, 1, negative 1, 1, 2, 4, negative 2, 4. And then the other one is negative 3 and 9 and 9. And it's all up there. Now let's join the points together. And that's how we join the points. Now let's draw the other graph. Okay, what's the y, the turning point? Let's figure out what the turning point is. Okay, the turning point for this one is 4. The turning point is 4. Okay, the turning point is 4. The turning point is 4 and negative 4 and a half. 4, negative 4 and a half, that's the turning point. Let's plot that one first. The turning point 4 and negative 4 and a half. 4 and negative 4 and a half. Here is the point, 4 and negative 4 and a half. Let's put it right in the middle. Right there it is, and then that's the turning point. Now let's draw the axis of symmetry, because that's exactly where the turning point is. And there is our axis of symmetry. That is our axis of symmetry. Now we know that the graph is going to look up. All right, what are the x-intercepts? The x-intercepts are 1, 1 and 7. So let's plot those. 1 and 7. The x-intercepts. 1. And the other one is 7. And then what is the y-intercept? The y-intercept for this one is 3.5. Let's go back to that page. The y-intercept is 3.5. Y-intercept is 3.5. Let's look for 3.5. There is 3.5. There is 3.5. Now let's join the points together. Let's fix that. Now let's join these points together. There. Okay, let me fix that. Now let's see what the graph calculator gave us. That's exactly the same graph that we've just drawn there. Now let's look at finding the equation of a shifted parabola. Basically, this parabola is shifted horizontally. That means to the left and right. If it's to the left, you add an m plus m. If it's to the right, you minus m. The parabola is shifted vertically. If it's shifted up and down, positive means that you plus n, and then down means that you minus n. Let's shift the parabola. We've got y equals to x squared minus 2x minus 3. If the parabola is shifted 1 unit to the right, determine the new equation of the parabola. If it's shifted 1 unit to the right, let's change back to my color. If it's shifted 1 unit to the right, therefore it means 1 unit to the right, it means therefore y equals to, the x's all are with minus 1. Where there's an x, you put x minus 1. And then now you multiply out. X minus 1 all squared, that's x squared minus 2x plus 1. That's minus 2x plus 2. Then you've got minus 3. Add like terms, you've got x squared minus 2x minus 2x, that's minus 4x. 1 plus 2, that's 3. 3 minus 3 is 0, so that is your final equation there. Now what happens when it's shifted along the y-axis vertically? If the parabola is shifted 3 units down, determine the new equation of the parabola. If this is shifted 3 units down, basically what you do is you minus 3. So that's x squared minus 2x minus 3 minus another 3. That's 3 units down, which is equals to x squared minus 2x minus 6. And that's how you figure out the new equation of the shifted parabola. Now let's find the equation of the parabola. Finding the equation of the parabola depends on the situation that you have. It depends on what the points given to you look like. If you've got all the intercepts given to you, both the x-intercepts and the y-intercept, you use this formula. You go y equals to a in bracket x minus x1 bracket x minus x2 and take it from there. So we're going to use y equals to a in bracket x minus x1 in bracket x minus x2. All right. The x-intercepts are what are the x-intercepts in this case? The x-intercepts are negative 0, 1, negative 0, 1, no, negative 1, 0, sorry, negative 1, 0, negative 1, 0, there's no negative 0. And the other one that we have is, the other one that you have is 4, 0. Now this is how you put them into the equation. Therefore the equation becomes y equals to a in bracket x plus 1, you go the opposite sign, that will be x minus 4, which is equals to a in bracket. Let's multiply the x's. So that's x squared minus 4x plus 1, that's minus 3x minus 4, which makes it a in bracket ax squared minus 3ax minus 4a. The y-intercept given to us here is, the y-intercept given to us is 0, 2. Y-intercept is 0, 2. We substitute that into the equation. How do we substitute that into the equation? The y-coordinate is 2 equals to, and the x-coordinate is 0. A 0 squared minus 3a 0 minus 4a. Therefore, y equals to, no, therefore 2 equals to, sorry. Therefore 2 equals to, these two are zeros, so you're left with minus 4a. 2 equals to negative 4a. Divide both sides by negative 4, you're left with negative 1 over 2 equals to a. Well, therefore, your y equals to negative half x squared minus 3 times minus half, that is equals to positive 3 over 2 plus 3 over 2 plus 3 over 2x. And the last one is minus 4 and minus half, that is equals to 2 plus 2. And that is the equation that you end up with. Next scenario is when you've got x-intercepts given to you and another point. You use the similar situation. So you still use y equals to a in bracket x minus 1, x minus x1 I mean, times x minus x2. Okay, x-intercepts given to you are here are the x-intercepts given to you: 1 and 0 and 5 and 0, 1 0 and 5 0. Therefore you substitute them. Therefore y equals to a in bracket x minus 1 times x minus 5, which is equals to a in bracket x squared minus 6x plus 5, which is equals to ax squared minus 6a x plus 5a. Okay, point, this point negative 112, point negative 112 lies on f, lies on y. Therefore 12 equals to a negative 1 all squared minus 6 a negative 1 plus 5 a. Therefore 12 equals to a plus 6a plus 5a. That is equals to 12a on the right hand side, 12a. Therefore 12 equals to 12a, meaning that therefore 1 equals to a. Therefore your y, the final equation is y equals to x squared minus 6x plus 5. And that's the final equation there. Now on the final scenario is if the turning point and another point are given to you, use the second standard format y equals to a in bracket x plus p all squared plus q. So we use that y equals to a in bracket x plus p all squared plus q. Okay, the turning point is given to us. The turning point has got the point negative 3, 1. Negative 3, 1. Remember, we know that the turning point is minus PQ. Therefore, y will be equals to a in bracket x plus p, which is 3, x plus 3, all squared plus 1. The other point, 1, 5 lies on the graph. Point 1, 5 lies on y. Therefore, y equals to, 5 equals to a in bracket 1 plus 3 all squared plus 1. Therefore, 5 equals to a times 4 all squared plus 1. We know that 4 all squared. Take the 1 to the left hand side. That's 5 minus 1 equals to a times 16. Therefore, 4 equals to 16a. Now, divide both sides by 16. So you've got 4 over 16 equals to 16 over 16a. Therefore, 1 over 4 equals to a. Meaning that, therefore, your final equation is equals to 1 over 4 in bracket x plus 3 all squared plus 1. And that is your final equation from a graph given to you. Now let's look at the average gradient. In this question, the question says, find the average gradient between 2 points, PA and GA and QA plus H and GA on a curve g of x equals to x squared, and then determine the average gradient between P2, G2 and Q5, G5. Explain what happens to the average gradient if Q moves closer to P. Let's start with the first one. Okay. The first one, to find the average gradient, what you do is you find the limit as h tends to 0 of g of a plus h minus g of a all over 2a all over a plus h minus a, which is equals to the limit as h tends to 0 of, we know that g of x equals to x squared. Let's just double check that. Yes, equals to x squared. So what happens, g of a plus h will be basically a plus h all squared minus a all squared all over h, which is equals to the limit as changed as h tends to 0. The limit as h tends to 0 of this you're going to do in more detail in grade 12. You're going to have a whole chapter on differential calculus which specializes on this one. So that's a squared plus 2ah plus h squared minus a squared all over h. That is equals to the limit as h tends to 0 of the a squared cancel out. I wanted to notice something. The a squared cancel out. A squared minus a squared. So you're left with 2ah. You are left with the limit as h tends to 0 of 2ah plus h squared all over h. Which when you factorize becomes the limit as h tends to 0 of take h out, and you're left with 2a plus h. 2a plus h all over h. The h's cancel out. The h's cancel out, and you're left with the limit as h tends to 0 of what? 2a plus h. Now what happens when as h tends to 0, h becomes 0? So the final answer there becomes 2a. And that is your answer there. Now let's go back to the question. The question asked, determine the average gradient between P of 2 and Q of 5. That should be easy. P of Q and Q of 5. Average gradient, number B, average gradient equals to G of 5 minus G of 2 all over 5 minus 2, which is equals to 5 squared minus 2 squared all over 3, which is equals to 25 minus 4 over 3. And 25 minus 4, take out a calculator. 25 minus 4, that is equals to 21 over 3. And we know that 21 over 3 is equals to 7. Take out a calculator too and just check it out. So that is equals to 7. So the average gradient between 5 and 2, x equals to 5 and 2 is equals to 7. Now the last question asks, explain what happens to the average gradient if Q moves closer to P. If Q moves closer and closer and closer to P, you're going to have an instantaneous gradient at P of A. So it will be an instantaneous gradient at P equals to A. Next question. The very last question. Given g of x equals to x squared minus x squared plus 1. Draw a sketch of g of x. The sketch will be very easy to draw. Alright, let's figure out what the a is. Alright, a equals to negative 1 here, meaning that it's less than 0, meaning that your graph looks down. The turning point, it's minus PQ, which is equals to 0, 1. And so we've got the turning point, the y-intercept. The y-intercept to make x 0. When you make x 0, what do you get? You get g equals to negative 0 all squared plus 1, which is equals to 1. Now the x-intercept, you make y 0. Make y 0. When you make y 0, what happens? 0 equals to minus x squared plus 1. Therefore, x squared equals to 1, meaning that therefore x equals to plus or minus 1. That is the x coordinate. Now the x-intercept. Now your range should be very easy. Your graph looks down, meaning that you have got a maximum turning point, meaning that your q, which is 1, is the maximum value. So y must be less than or equals to 1. So it looks down y equals to less than or equals to 1. Now let's draw the graph. Now let's draw the graph. When we draw the graph, let's draw the graph of y equals to x equals to 0 first. You don't have to do this. I'm doing this so that you can see how it compares with the new one. So that's 1, negative 1, 1, and then 2, 4. Minus 2, 4, 2. Alright, now let's join the points together. Let's join the other points together. Right, now let's draw the graph of y equals to minus x squared plus 1. It's going to be a blue graph. Now let's go back to the turning point. The turning point is 0, 1, 0, 1. Let's draw that first. 0, 1. There is the turning point. Now the x-intercepts are 1 and negative 1. And now we can draw the graph. Let's join the points together. It will be very easy to join the points together now. And on the other side. That's the graph that we need to run. Now using the graph calculator, that's what we got. It's exactly the same as what we needed to get. Now let's look at the other questions. Determine the average gradient of the curve between x equals to negative 2 and x equals to 1. X equals to negative 2 and x equals to 1. G of x equals to negative 2 and g of x equals to 1. Let's take it back to my favorite color. Okay, average gradient, that's B. B, average gradient equals to g of 1 minus g of negative 2. Okay, let's just double check that. G of 1 and g of negative 2. Yes, that's correct. G of 1 and g of negative 2 all over 1 minus negative 2, which is equals to g of x. Remember, g of x equals to negative x squared plus 1. So g of 1 will be equals to, g of 1 is minus 1 all squared plus 1 minus, in bracket, minus negative 2 all squared plus 1. Okay, let's try and take this down a bit. Okay, so that's equals to minus 1 all squared plus 1 minus negative 2 plus all squared plus 1 all over 1 plus 2, which is equals to, that is equals to minus 1 plus 1 minus 1 plus 1 minus negative 4 plus 1. negative 4 plus 1 all over 3, which is equals to negative 1 plus 1 is 0, so that's 0, minus negative 4 plus 1, that's negative 3 all over 3, so that's equals to 3 over 3, which is equals to 1. So that is the average gradient between 1 and negative 2. Now next question. Determine the gradient of g at x equals to 2. At x equals to 2, what is the gradient of g? Okay, to find what the gradient of g is at any general point, right? Let's first find the average gradient, that's in average gradient in general, which is equals to the limit as h tends to 0 of g of x plus h minus g of x all over h. That will be equals to the limit as h tends to 0 of minus x plus h all squared plus 1 minus x plus h all squared plus 1 minus negative x squared plus 1 all over h, which is equals to the limit as h tends to 0. Stay with me here. That's negative x squared minus 2xh minus h squared plus 1 minus, okay, plus x squared minus 1 all over h, which will be equals to the limit as h tends to 0 of, here are the ones that are now going to cancel each other out. Okay, the minus x squared will cancel with x squared, the 1 will be cancelled with minus 1. You will be left with minus 2xh minus h squared minus 2xh minus 2xh minus h squared all over h, which is equals to the limit as h tends to 0. Then you take the h out, factorize, you're left with minus 2x minus h all over h. And then the h's cancel out. The h's cancel out now. Now that the h's have cancelled out, this is what you have left. That is equals to the limit as h tends to 0 of negative 2x minus h. Now as h tends to 0, that leaves you with minus 2x. Now at x equals to, that was number C, at x equals to 2, at x equals to 2, at x equals to 2, the average gradient equals to negative 2 times 2, which is equals to negative 4. Number D, at x equals to 0, the average gradient is equals to negative 2 times 0, which is equals to 0. And that is the end. We've come to the end of this video. Thank you so much for watching. See you in the next one. Bye.